Picture this. You're lying in bed, burning up with fever, reaching for that bottle of medicine to make it all go away. But what if I told you that you might be interfering with one of your body's most ancient and powerful weapons? That uncomfortable heat coursing through your body isn't just a side effect of being sick. It's a carefully orchestrated defense mechanism honed by evolution over hundreds of millions of years. When a fever hits, it doesn't feel helpful. It feels exhausting. You shiver, you sweat, your muscles ache, and your mind is foggy. All you want is for it to stop. But behind the scenes, while you suffer, invading germs are experiencing a far worse fate. They're being slowly destroyed by rising temperatures they simply can't withstand. Fever is one of nature's most sophisticated defense systems seen across countless species. From lizards basking longer in the sun when ill, to fish seeking warmer waters, to bees collectively heating up their hive to combat infections, fever isn't just a human trait, but as warm-blooded mammals, we take it further. Our internal thermostat can raise the body's temperature significantly, creating an inhospitable environment for invading pathogens. So why is this heat so effective? Every organism has a narrow temperature range in which its biology functions properly. For humans, that sweet spot is around 37 degrees Celsius, 98.6 degrees Fahrenheit. Our metabolic processes, enzyme functions, and immune responses are optimized for this range. Pathogens, too, thrive within specific temperatures. When fever pushes our internal temperature beyond that range, microbial life begins to falter. It begins with pyrogens, chemical messengers produced by immune cells or released by pathogens. These molecules signal the brain's hypothalamus to reset the body's temperature set point. Suddenly, your body thinks it's too cold, even if it's already at a healthy temperature. In response, muscles contract, shivering, and blood vessels near the skin constrict, conserving heat in the core. The result? You feel cold outside while burning inside. This process is energetically expensive. For every degree of fever, your body uses about 10% more energy. That's why fever feels draining. Your body is diverting resources to fuel this internal war effort. But it's worth it. As the temperature rises, bacteria struggle. Their membranes become unstable, proteins misfold, DNA gets damaged, and their ability to reproduce collapses. They're being cooked alive. What about our own cells? Fever does stress them too, but unlike pathogens, our immune system becomes more efficient under heat. White blood cells like neutrophils, macrophages, and killer T cells operate more aggressively. Fever acts like a performance enhancer for immunity, speeding up detection, attack, and destruction of invaders. Even more impressive, fever triggers our immune system to deprive pathogens of key nutrients. Iron, glucose, and amino acids are sequestered away, making the internal environment even more hostile. Pathogens that aren't killed by the heat may starve instead. Viruses face similar problems. The rhinovirus, which causes the common cold, thrives in the cooler environment of the nasal passages. Raise the temperature, and this safe haven disappears. Fever also prompts infected cells to produce heat shock proteins, a last-ditch effort to repair themselves. Ironically, these same proteins signal immune cells to destroy the infected cells, speeding up viral clearance. And yet, despite fever's power, most of us instinctively reach for medication at the first sign of discomfort. This reflex is understandable. Fever is unpleasant, but it's also recent. For most of human history, fever ran its course. Modern antipyretics like aspirin and ibuprofen have only been widely available for about a century. And while they bring relief, they may interfere with the body's natural defenses. Scientific studies show that in many cases, fever under 40 degrees Celsius, 104 degrees Fahrenheit, is not dangerous and doesn't require treatment. Suppressing fever too early may prolong illness or reduce the immune system's effectiveness. One study on critically ill patients showed that aggressively treating fever was associated with higher mortality, leading to early termination of the trial. Though ethical constraints make these studies difficult, mounting evidence suggests that moderate fever can be beneficial. There are, of course, exceptions. People with compromised health, such as the elderly pregnant women or those with neurological injuries, may be less able to tolerate the stress of fever. And when fever exceeds 40 degrees Celsius, medical intervention is necessary. But for the average person with a routine infection, fever is not the enemy. It's the body doing what it evolved to do. So why haven't pathogens evolved to resist fever more effectively? Some have tried. The measles virus, for instance, uses a hit-and-run strategy, spreading rapidly before fever takes hold. Other microbes adapt to survive fever's heat, but this makes them less effective in infecting healthy individuals with normal body temperatures. It's an evolutionary dilemma. Adapt to fever and lose efficiency elsewhere, or remain optimized and fall victim to heat. In the end, fever remains one of evolution's most elegant defense strategies, a multi-layered assault involving heat, nutrient restriction, immune amplification, and targeted destruction. It may feel terrible, but it's saving your life. And yet, there's more to this story, because understanding fever is only the beginning of understanding your immune system. Fever is just one component of an incredibly complex network of checks, balances, and counterattacks that have evolved over hundreds of millions of years. When pathogens enter your body, your immune system responds in waves. First come the physical barriers like skin and mucous membranes. Then, chemical responses flood the bloodstream, enzymes, cytokines, and complement proteins that neutralize threats or call for backup. Fever sits in the middle of this cascade, amplifying everything else. Heat increases blood flow to infected areas, delivering more immune cells. It enhances antigen presentation, how your immune system sees threats. And it even helps shape your adaptive immunity, the part of the immune system that remembers invaders for the future. Think of it as a symphony. Fever isn't a solo, but a crescendo. It makes the entire immune orchestra play louder, faster, and stronger. That's why researchers today are revisiting how we treat fever, not just in infections, but in broader contexts. In cancer immunotherapy, for instance, fever-range hypothermia is being studied as a way to boost immune activity against tumours. In vaccine development, scientists are learning how fever shapes immune memory, influencing long-term effectiveness. We've also learned that not all fevers are the same. The pattern, duration, and degree of fever can give doctors vital clues about the nature of an illness. A low-grade, prolonged fever might suggest tuberculosis or autoimmune disease, while a sharp, sudden spike could point to a bacterial infection. In this sense, fever is not just a weapon, it's also a signal, a form of communication from within. So next time you're lying in bed, drenched in sweat, aching and miserable, remember, what you're experiencing isn't just a symptom, it's a story. A story of survival, of ancient biology doing battle in your name, of trillions of cells working in coordinated defense. And yes, you may still reach for the medicine. There's nothing wrong with relief, but now you'll do it with a deeper appreciation. You'll know that beneath the discomfort, your body is doing something extraordinary. If this exploration of fever has sparked your curiosity, there's so much more to uncover. The human body is packed with defense mechanisms just as fascinating. From the blood-brain barrier to programmed cell death, from microbial communication to the microbiome, each layer reveals new insights into how we survive in a world full of microscopic threats. So subscribe and follow along as we dive deeper into the hidden genius of human biology. Because every fever, every cough, every ache isn't just illness, it's evolution in action.